Let's continue with the problem. So we have found out the global stiffness matrix. Next we will have to find out the element load vector. So let's find out the load vector due to the body force, and that is given by Fi equals to Ai Li F upon 2 1 1. So for element 1, F1 will be equals to A1 L1 F divided by 2 1 1. Similarly, F2 will be A2 L2 into F upon 2 1 1. F3 equals to A3 L3 F upon 2, and F4 equals to L4 F upon 2 1 1. So let's write down the degrees of freedom for this as well. So it is 1 2 2 3 3 4 and 4 5. Okay, similarly let's write down the traction force, which is given by Ti Li upon 2 1 1. So I'm writing this down for each and every element. Okay, so we have body force, we have traction force, and finally we have another point force which is applied at only at node 2, which is P2. To find out the global stiffness vector, capital F will be, since there are 5 nodes, so it will be a column vector of 1 by 5. So at 1 we have this term and this term. So it is A1 L1 F by 2 plus T1 L1 upon 2. Okay, so this is 1 of 1. Now 2 of 2 will be A1 L1 F by 2. Now you see there are 2 terms here, so this will be, this term and this term. Okay, so we have the element like this, right? So there will be half here, half here. At node 2 again there will be half here and half here. So there are 2 contribution towards node 2. So plus A2 L2 F upon 2. Similarly here again there will be 2 plus T1 L1 by 2 plus T2 L2 by 2. In addition to this, at node 2 we have a force P2. Okay. At 3 we will have A2 L2 F by 2 plus A3 L3 F by 2 plus T2 L2 by 2 plus T3 L3 by 2. There is no point force there. Let us write this down for the other nodes as well. The contribution from either side of the node. And finally, this will be F by 2 plus T4 L4 by 2. So this is the global load vector. So we found out the global stiffness matrix and the global force vector. So finally, it is to be written as kg, that is the global stiffness stiffness matrix, into Q equals to Fg. Okay, so here you will have a 5 by 5 matrix multiplied by Q1, Q2, Q3, Q4, Q5 equals to this matrix here. Now you will have 5 equations and 5 unknowns. So the equation have to be solved simultaneously to get the values of Q1, Q2, Q3, Q4 and Q5. So this solves this problem of a stepped shaft element. That's all for this lecture. Thank you.